Okay, so this first lab, the whole purpose of it is going to be to show you how to just run a program. We're not necessarily going to be writing any code yet for this first lab, so that's good. It should be very, very short, and short enough such that ideally you guys would finish this in like 30 minutes and then start in the second lab and get a week ahead. But yeah, let's just get started. So first off, we're going to go here into Vivado. Loading. Click it again. Oh, there it is. Wonderful. All right. So the first thing you're going to do is you're going to create a project. Next. Um, then you're going to name it whatever you want, and you're going to pick whatever folder you want in your computer. It could be anywhere, but I would recommend making a folder specifically for this in your personal laptop. So then once you do that, you're going to click next. Then you select RTL project. Okay. What you're going to do here is we're going to create a source file. I like to just call it NF because this is what I view as the normal file, because this is where we write all of our normal code. Just a good normal file. Okay, the constraints file. This I like to call CF for constraint file. It's not at all a normal file because it's not where you do your real programming, but it matters. We'll get to what it does later. So CF. Okay, I'm gonna click next there. Okay, here is the part where a lot of confusion is gonna arise, but no need to fear. We'll all be taken care of right here in this video. Like literally, I remember when I first took DSD, I spent like 30 minutes just on this part, and so did everyone else. But that'll all be resolved right. That will all be resolved right here. Okay, so the family is going to be Arctic 7. The package is going to be CSG324. The part number, okay, so what we are going to be using in this course is XC7A100T CSG 324-1. So this right here is what we need to pick. Go back to next. Okay, and then finish. Okay, yes. Okay, so now we can start writing our code. For your first lab, you're not gonna need to write anything. It's just gonna be given to you. You're gonna be given the constraint file. Oh, let me show you this, the constraint file location. So right here is your constraint file, and then this top one is your normal file. Your normal file will start off with that, with the, like, yeah, it's gonna start off like this, and then you just delete this. Okay. Um, Although you won't necessarily need to be writing any code, I'll just write some stuff just to give you guys a sneak peek as to how some basic stuff works. So what I'm gonna do is, what I like to do is I like to close this and I like to define stuff. So LED, so that's gonna be a thing. All your inputs and outputs go in the top. Only inputs and outputs. Okay, then we're gonna name it being output LED, and then assign LED equals 1. Yeah, semicolon. Okay. So, now let's look at the constraint file. Okay, so what the constraint file is going to do is it's going to map the inputs and outputs we defined here to a physical part on the board. So the constraint file, fortunately for us, the constraint file, you don't really need to write anything. You can just Google stuff, like here, let's do that. Constraint file Nexus 7. Okay. And then, hold on. Should be, yeah, right here. Should be available online, so I'm going to copy that. We're going to go back into Vivado. Now we're just going to copy and paste that. So, okay. So this here is our constraint file. So this controls the physical switches. What you want to map that is, well, that's going to be used as an input, obviously. LEDs. Okay, so this is the part we want to manipulate. So let's say we want to turn on one LED. What we're going to do is, you see how we define this as an output LED? Then what we're going to do is we're going to go here and we're just going to name it LED. We should save, and then we should generate the bit stream. So yeah, save. Save that one. Save that one. So yeah, now that that's done, just generate the bit stream and it should be good to go. So yeah, here at the top, it's loading up. It does take time, unfortunately. I may edit the amount of time it takes. It will probably only take around 2 minutes for these lower level labs, but in the future it can take up to 20 minutes long to compile, or not compile, but load the bitstream. Like, yeah, I remember when I took digital systems design for the VGA portion of my project for the tech symposium competition. I remember it would just synthesize for like 20 minutes, and I would synthesize, load it, and it would, if it didn't work, I would have to make a change and then submit it and then wait a whole another 20 minutes. So sometimes I'd be there for like 5 hours just to get like 10 iterations tested. But yeah. And I also won the tech symposium for digital systems design. So yeah, that's just a fact about your TA. But how seriously I take this. Okay, so it has been successfully completed. Okay, so you just click that. Happening here. Oh yeah, there's other stuff. I think this right here, the RTL analysis, open elaborated design. See what this does. I think this is what I want to show you guys right now before we actually. Oh yes, right here. So yeah, this right here is how you generate the schematic, the electrical schematic of the code you've made. It's really nice. I love this feature because if you're very proficient in circuit design, like if you really liked Dr. Young Jong Jo's classes, Dr. Ju, then you're gonna like this because you can always just, if for some reason coding isn't your forte, you can always see what gets generated and then use conventional circuit design techniques to identify the problem. And then you can convert your circuit that you made manually into Verilog, which is a fairly straightforward process. And then it should just run. So if you're not good at coding, you can always fall back on your circuit design skills. So that's one really good thing about FPGA. It really ties in, encompasses all of electrical engineering. Okay. Okay, so now that we looked at that, okay, so we're going to want to go into the hardware. Let's go back. Yeah, it's hardware code there. Okay, so now, sorry about that, actually. But so now we're going to go into the hardware manager. Okay, so then we're going to click Open Target, Auto Connect, and let me see if you can see it. See, the LED should turn on right there. Oh, well, hold on. Let me program the device. Let me bring this closer so you guys can see it. Oh no, one of these LEDs is going to turn on. LED 1. Oh, program, yeah. Oh yeah, right there. You see that? That turned on. And that's exactly what we wanted it to do. Because that's what we wrote the code for. So yeah, and I guess I can teach you guys some more stuff. Oh, well, yeah, for lab 1, pretty much what's going to happen is Dr. Morton, he's going to give you a file, normal code like this, and then he's also going to give you a constraint file, and your job is literally to just cut and paste it in there and then run it and see what it does. That was the first lab for last semester's digital systems design course, so it will most likely be the same thing. Okay, but yeah, you guys are probably thinking about this right here. Why is there LED in brackets in these numbers? LED bracket 1, bracket 2, bracket 3. Well, the answer is because one really efficient way of defining stuff in the constraint file is to use an array. So let's say we wanted to do output 15 0. You would just do this, and then you can control very quickly which one you want there. So we see now we named it LED 0. That's gonna be 1 for high, LED 0. And let's uncomment all of them. You have to uncomment them in order for it to become active. Wait, hold on. I want to see something. Yeah, this we might uncover. Yeah, let's try and run that real quick and see what happens. An error might come, but if it does come, that would be a good thing because then it will point out a somewhat important error that you guys can run into, and will hopefully prevent you guys from having a lot of headaches if we uncover this. Yeah, the bit stream takes a while to generate. Ah, yes, wonderful. So we see how it failed? It's because we defined some stuff here, like you see how, because we have it as an array, what that means is the constraint file is going to look for the whole array. It sees, yeah, that got defined. But um what about section 15 to 1? What about that? Yeah, that didn't get defined in the constraint file because it got uncommented. If we go to the yeah, because it didn't get uncommented. If we go to the messages, or errors, hold on. Yeah, it's citing, hold on. Yeah, right here, you can see how it says LED 1 all the way up to 15 and not 0. It's because those are the ones that are the problem. And they're the problem is they didn't get uncommented. So you're always going to want to uncomment your stuff in your constraint file. Okay, and yeah, so now if we save that and go here and generate the bitstream, it should work. Oh, well, hold on. Here, let's cancel that real quick just to make something more interesting. I don't know, make it 3. A program. I do go generate the bitstream. Yeah, it does take a while. I guess you guys can just, anytime a bitstream is generating, you guys can just skip forward in the video until it generates. I may just edit these parts out in future videos. There we go. So, as you can see right now, it's the same output as before, just one LED's on. So we're going to go to the hardware manager, then program device, that, and program. And then you should see another LED turn on. Oh yeah, that one turned on. And yeah. So that's pretty much all you need to know for lab 1. Um um I guess I'll continue the video and show you guys some more just good little tricks and just stuff to get you started. And yeah, but if you want to just quit the video and just go do the lab and just like all you're going to need to do when you go in there is Morton is going to give you 2 text files you're going to cut and paste the normal file into there, into, hold on, where is it? Where is it? Add sources. Okay, yeah, I remember at the start of the video, there was a little thing here. Okay. Maybe it's under sources? Um, I don't know. Whatever. Okay. So, yeah, let's say we want to add an input. Input. Do is common. We'll do S or no SWITCH switch. Okay. So what we're gonna do, we're gonna do input switch and then actually no, it might be a little bit more complex than just me being able to quickly show you because we might need to make this thing called an always block to have there be an if statement is if let's see if we do this, I bet you an error is gonna come. Here, I'm just writing stuff now. Just to see if it really is this easy just to do it off the top of my head. Do it. And then that's gonna be C. And then oh yeah, this error in here. And don't be too intimidated by this. All of this will be explained later in videos. This is just me trying to just show you guys a bit more interesting thing than just an LED. Um so oh yeah, this error, anytime you get this, it's because you need to say what kind of output it is. I think it's gonna be output reg, I think. Yeah, output reg. Yeah, you gotta define it as a register, not a wire, whenever it's in an always block. And yeah. Um so now we need to go to the constraint file. Let's declare this switch. So that's going to make one of the switch be an input. And then we need to find where the clock is. Okay, it's right there, already been done. Okay, good. Um, okay, so ideally what would happen is when we turn on the switch, it would be able to turn the LEDs on and off. But, I mean, let's hope that happens. 'Cause I never can never be too sure about Vivado. There's always just thousands of ways to go wrong. Yeah, so the synthesis is running. And if you guys ever have any questions, just feel free to email me. Like, it doesn't even matter what time. Like, if you really need help, we can just have, I don't know, a Zoom session or something. Because yeah, the whole reason why I'm doing this is just to make sure that it's taught well. Because I remember when I went to digital systems design, I would say around 20% of people that took the class with me said they honestly felt like they learned nothing. It was like, or maybe not like, more like 60% of the people that I took this class with were like that. And that's not good considering how important this is. So, I mean, I happen to learn it somehow. So, I'm gonna do my best um to help you guys. Hopefully. Okay. So, okay, program the device. Okay, I hope that worked. Oh my. Let me see if it's working or not. This isn't good. As you can see, when I press the switches, nothing happens. So we need to debug it somehow. Hmm. Oh, maybe, maybe because maybe it's because of this. Maybe we gotta make it be like this. Like we have to define all cases. And if this doesn't work, then I don't know. That's not good. Hold on, let me see something. Um, Shit, nothing's happening. Hmm. I don't know. Hmm. I don't think this is gonna be right. Yeah. Um. Maybe this will change something. I guess while that's loading, actually, nah, I don't need to bring that up. Just gonna look at past design stuff. Oh, well, I guess I can tell you guys more about me during this interval of the bitstream generating. I work at Southwest Research Institute right now, so, and I'm specifically working on an FPGA based project for them. So, um, I'll try my best to incorporate practical stuff in the labs, or even make my own labs or extra credit opportunities that can expose you guys to some really important stuff that happens at Southwest. And Southwest, that is, it's like NASA with what we do there. If it doesn't work, we might need to call it quits because I mean this is all just completely extra, just for if you choose to stick around. You like yeah. Oh, wonderful. Okay, so apparently that was what did it. So now when you the switch up and down, that changes it exactly like we wanted. Okay, so now that you know the most important thing, which is how to do this, let's try and explain some of what's going on. So, um, up here, well, this is always going to be an every Verilog thing, always for some reason. Well, not for some reason, it defines I guess the time scale that the clock is operating on or something like that. But you don't need to think about that. That's just, you memorize that as a fact. That always goes up there. And then your inputs and outputs go there. And then you're going to have your inputs and outputs defined again down here, and you're going to add little details to them, like that it's an output or an input. And then, or if it's a register. And then if you want to have there be an if statement, you have to always put it in an always block, I think. I think. Could be where you don't, but I I don't want to just give you wrong answers because I'm pretty sure more it's going to have that be a thing that you need to know. So, um, I don't know. I can't find it. I guess it'll be a little bit of a mystery. Okay, so I mean, I'm pretty sure you can't. If you it doesn't have to be a mystery. You could just I don't know. Let's just see what happens. Pretty sure you cannot put a switch out there. Yeah, yeah, there it is. So yeah, an if statement can only go in an always block. So when we wanted to set a condition to determine whether or not to turn on the LED, we needed an always block. And the always block notation is going to be always and then that little symbol there. And then what goes in there, I think that's called the sensitivity list. It's going to be what it's going to be the clock. Yeah, 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 because it's going to be the thing that goes in the sensitivity list. I think it's an edge signal. Like, so what that means is like on the rising edge of the clock, it's going to execute all the code that's in there. So here, if you have a very, very fast clock, there's going to be a whole bunch of rising edges happening very quickly. So it's going to be sampling that almost, it's going to look like it's happening almost instantaneously. But if you were to slow this down with a whole separate clock divider module that we will discuss in future labs, then and then use that as your thing in there, that modified clock, then there would probably be some kind of delay of all the stuff that's going on in there because it's all synchronized with that clock. And then in here, you obviously just put in your if statements. And then, oh, important thing is going to be double equal signs for here and double equal signs for there because it's not assigning, it's just checking. And then, and then this it gets kind of confusing because there's three different ways of setting something equal to something. There's the blocking way and then the non-blocking way. Um, there's this way, and for some reason that didn't work. Morton will Morton will have lectures on how that goes, and I'll probably cover a video in the future explaining more what that is. And then there's just the plain equal sign, which is it seems to be fairly reliable since that worked. And then there's the assign like I don't know y equals x equals 1. There's the assign, which I don't believe you can put in an always block. Or if you could, it's not recommended. Let's just see. Yeah, you cannot do it. You cannot put in an assign statement in an always block. Must be out. And this equal sign right there, I believe that is considered blocking assignments because it forces everything to go in sequentially. But when you have this, it means everything's going on in parallel, I think. So, yeah. Okay, well, let me just show you guys again. Okay. So, yeah, that encompasses all of what you need to know for Lab 1 and a whole lot extra. Because literally you only need to watch like the first 5 minutes to, I guess, of this video to be able to just walk in there and then do what you need to do in 30 minutes. But like I said, it's important that you actually learn how to do this properly. Because when you go into industry, if you want to be doing something that is like very hard and important, something that will advance us technologically, then you need to learn this. And yeah. So yeah, that's all that I have for today. So off. I need to move. 41 minutes. All right. Bye.